carbon dioxide levels are the highest in 800,000 years. Some folks argue our storms are stronger, there's more flooding, there's more hurricanes. Could it have something to do with this?
Is CO2 really the villain we've been led to believe?
CO2 is no more a villain for climate change than witches were, 200 years ago. And here we have a movement of crazies who want to eliminate CO2. It's a suicide pact. Nobody wants to commit suicide. But in the meantime, enormous damage can be done. CO2 is increasing very, very rapidly now, but temperature is not. Far from being a villain, it's absolutely essential for life. And the only real effect today is that the whole Earth is getting greener.
You might be wondering, why am I exploring the climate conversation and why now? The truth is, I began to notice eerily familiar patterns between the way we were told to trust the science during COVID and the way we're now told to trust the science on climate. The same tactics, alarmism, groupthink, narrative control, censorship, corrupt science. And once again, those who ask questions are labeled as heretics. That's why I'm excited to explore the science, the politics, and the deeper conversations that we need to have to move beyond the dogma and start getting closer to the truth. Beginning in this episode with Dr. William Happer, a world-renowned physicist, a former White House science advisor, and one of the most credentialed voices challenging today's dominant climate narratives. And I'll be honest with you, despite the credibility of guests like Dr. Happer, conversations like this still risk being throttled, censored, or worse on platforms like YouTube. So if you value these kinds of deep, unfiltered discussions, here's what I'd ask. Please hit subscribe right now to make sure you keep up to date with everything that we're publishing. And more importantly, please do this. Join our mailing list at danastingregory.com/podcast. You'll see the link in the comments below. That way, no matter what the content platforms do, and believe me, we've been censored plenty of times. We even got deplatformed during COVID. So if anything happens to this episode or any of our content, if you're on our mailing list, then we can still reach you. So please do that now. Go to danastingregory.com/podcast and we will keep in touch. Thanks again. I look forward to this episode. Please welcome Dr. William Happer. Dr. Happer, is CO2 really the villain we've been led to believe? What are we getting wrong about CO2?
Well, no, CO2 is no more a villain for climate change than witches were, 200 years ago. It's the same sort of superstitious belief of most people that led to, the tragedies of witch burnings. Witches were accused of causing bad weather, storms, harvest failures, all the same things that are being piled onto CO2 today. And, CO2, far from being a villain, it's absolutely essential for life. We live on plants, and plants make the food that we eat from three things. One is water, one is carbon dioxide, the villain from the air, and the other is sunlight. And without those three, we would all starve to death. It doesn't matter which one of them you eliminate, we all die. And here we have a movement of crazies who want to eliminate CO2. Just to give you a feeling for it, each of us breathes out about 2 pounds of CO2 a day. That's a lot of CO2 when you multiply by 8 billion people in the world. So if CO2 is demonized, it's really demonizing people. That's the essence of it. And I have some people I don't like, but most of them I like. I don't see why they should be demonized, right? But they are, and if you really scratch the surface of these fanatics, that's what they really hate. They hate people. And so the whole thing is nuts. CO2, if you look at the geological history of the Earth, has always gone up and down. We're actually in a CO2 famine today compared to geological history. Over most of the modern history of geology, the last 500 million years or so, the Earth is much older than that, but CO2 levels have been 3 times, 4 times, 5 times higher over most of that period of time. And the only real effect you can see from CO2 today is that the whole Earth is getting greener. plants are having a much easier time growing, especially in arid regions of the earth than they used to have with lower CO2 levels. And more will be better. So the answer is it's not a villain at all. It's a benefit to life.
Okay, so I mean that I can understand, and what I suppose I'm curious about within the example that you've given, often the climate change movement has a very limited reference span in terms of the climate observable data, but obviously we can make deductions about historical CO2 levels, and I understand the point about the beneficial aspect on plant life. And the climate movement often talks about, the world ending. Well, I personally believe the world will survive long after we do. But to what extent is there an upper limit on where CO2 is no longer healthy for natural life, including humans?
Oh, yes, absolutely. And we've studied that very, very carefully in connection with space astronauts who live in confined spaces and submarine crews, who are underwater for 3 months at a time and have to live in a controlled atmosphere. So, in our U.S. Navy, the upper limit is 5,000 parts per million. For reference, that's more than a factor of 10 what we have today. And there's no way you could make the outside air 5,000 parts per million. There's not enough coal and oil to do that. But anyway, at that level, you can't see any effect. And you can sort of do in your head what would really be dangerous. Our breath, when you exhale, is about 4% CO2. And so if you inhale the same breath, you would not feel very good because you're not exchanging the CO2 that you produce in your body. I mentioned we produce about 2 pounds a day, and you have to get rid of that by breathing. You breathe to get rid of CO2. It's not to get oxygen. It's to get rid of the CO2 that you're generating. And so it's harder for the lung to expel CO2 when it sees air coming in at 4%, which is what it would like to expel air at. So certainly 4% is very dangerous, and you might survive for a little while at 4%, but that's 40,000 parts per million compared to 4,000 today. So there's no way we will ever approach those dangerous levels in practice. But it's good to keep them in mind,
Yeah, and then is the same true for plant life? Is there an upper limit for plant life and other natural life?
Plant life is quite happy at 4%. It grows okay.
Yeah.
But animals have a hard time.
Okay. And coming to the kind of, I suppose, the crucial point in the conversation around climate change, to what extent does the level of CO2 in the atmosphere, whether naturally occurring or human created, actually contribute to temperature change on Earth? How significant is it as a variable?
As a variable for affecting the Earth's temperature? Is that the question?
Yes, it is.
Well, yeah, CO2 is a greenhouse gas. That means that on a clear day with no cloud, most sunlight will go right through CO2 to the surface and heat the surface. And the surface tries to keep itself cool by radiating back into cold space, but it radiates at much longer wavelengths. And the longer wavelengths of radiation from the Earth's surface are absorbed by CO2. CO2 is not transparent to thermal radiation. And so the surface has to work a little harder and get a little warmer if there's more CO2. So, of course, it will cause some warming, but the amount of warming has been enormously exaggerated. My own, educated estimate is a bit less than 1 degree centigrade for every doubling. And that's probably a little bit overestimate, but first approximation, that's what you would get. And doubling, that means going to 860 parts per million from today's 430. That would take more than a century. So we've got lots and lots of time to make sure that we've made this estimate right. There is no emergency to worry about. But it's a very ineffective greenhouse gas. By far the most effective control of Earth's temperature is clouds. they work a little bit like greenhouse gases. They're not quite the same because clouds do scatter sunlight coming in, but they also hinder the cooling of the earth. And if you've ever, been camping or something like that, you get a lot colder sleeping out on a clear night, than if it's cloudy. The clouds help to keep the heat in overnight. And so the big driver of Earth's climate is really clouds.
Okay, I want to come back to talk about that. Before we do, I just want to understand the kind of, you've kind of already answered the question in terms of alternatives, but how does the level of CO2 in the Earth's atmosphere vary compared to history? I appreciate that we've only got approximately 100 or so years of data on it, but theoretically, have we lived through periods of history where there is significantly higher levels of CO2 in the atmosphere?
Well, yes, humans were probably around, 100,000 years ago, which was the last interglacial period. And CO2 levels then were just as high as they are today. They may have been a little bit higher. But over most of the intervening period, there's been an ice age, where North America, Scandinavia was covered with ice and the seas were colder, so CO2 levels were much lower for the most of the last 100,000 years. They were down at 200 parts per million instead of 280 or so, which is what they started at 200 years ago. So at least for the last several million years, we've been in and out of one ice age after another. Nobody's quite sure what has caused this. We didn't used to have ice ages like this. Say 10 million years ago, there weren't ice ages. So it's something that started 3 million years ago, roughly, maybe 5. And it's just gradually gotten worse. Nobody quite knows why. But when I was a young man, you could make a career by writing papers about the coming ice age, and you got funded generously. And of course, it was all due to humans.
A quick break to tell you about something really important. It's becoming increasingly difficult to speak freely without fear of being silenced. With the UK's online safety bill now in force, surveillance powers are expanding and censorship is only accelerating. That's why more and more people are waking up, and Proton VPN just became the #1 most downloaded app in the UK Apple App Store. It's built by CERN scientists based in Switzerland and fully open source. Proton VPN is one of the few privacy tools that genuinely walks the talk. When another big name VPN rejected us for misaligned values, Proton welcomed us because they support real free speech. So head to danastingregory.com/Proton or hit the link in the show notes to find out how you can protect your privacy and support what we do. Now back to the conversation.
And then, the Earth stopped cooling about 1980, in the 50s, 60s, 70s, the Earth was getting cooler. It was quite obvious. And that was driving alarm about the next ice age. And then that stopped and it began to warm a little. And so many of the same people who had written alarmist papers about the coming ice age started writing alarmist papers about global warming. It didn't matter just as long as it was alarmist and it brought in lots of funding. That was all they needed. The idea that it should be true, the last thing that bothered them.
Well, yeah, I mean, I have a theory that's why it was relabeled climate change, because it enables you to create stories in either direction, because it's no longer about warming or cooling. It's just about whichever, the fact that it moves and has done since the dawn of time. But that's my skeptical voice coming through. Now, is there a correlation throughout history of the temperature variance and CO2, and which is the dog and which is the tail? If you get
well, yes, indeed, that's a good question, and that depends on the time scale that you're asking. So, for example, CO2 is increasing very, very rapidly now, but temperature is not. And if you look at the last 10,000 years since the end of the last ice age, we're in an interglacial period now. Over most of that period, CO2 levels hovered around 280 parts per million. There were modest warmings and coolings, but they didn't change the CO2 level very much. If you look over even longer time scales, say the last 2 million, 3 million years, there have been these periodic big continental glaciers, and whenever it was very cold, CO2 levels went down to 200 parts per million or so, and in the interglacials, it warmed up again, and it came up to closer to 300. So it was fluctuating between about 200 and 300 parts per million. When it was cold, it was low. When it was high, it was higher. But the evidence is very clear that it was the temperature that caused CO2 to go up. If the temperature went up, because the temperature would go up first, and then a little bit later, hundreds of years later, CO2 would go up, or the temperature would go down, and a few years later, CO2 would go down. So the cause of this correlation was changing temperature. It was temperature, causing CO2 to go up and down, not vice versa. And people are often confusing cause and effect, as Michael Crichton, who was a big skeptic of all of this nonsense before he died, said it's sort of the wet streets cause rain, syndrome, so there's been a lot of that in the climate area.
Well, I can see that, and as a result, that idea that it's directly correlated is what seemingly is driving a lot of the policy decisions, and the policy decisions are vast. So my question to you is, what would your greatest critics say about what you've just said? How do they justify the relationship between carbon and the climate?
Well, the most honest ones would probably agree with me, but they wouldn't admit it publicly. But, a more likely answer is that, 97% of climate scientists agree there's a problem, and how dare you disagree with 97% of the scientists? And so they have tried to convince the public that science is, the laws of science are like, the laws of Parliament or the laws of Congress. The legislators get together and they vote on a law, and that's the law. But that's really not the way of the laws of nature. The laws of nature don't give a damn what humans vote. And so anyway, they will do their best to try to confuse human laws with nature's laws. And there they do pretty well, because they've had huge amounts of money. So they've got lots of hireling scientists who will happily, vote that there's an emergency, and just keep the money coming to our research group, sir. And
yeah, well, Wikipedia now claims that the consensus is 100%, apparently. So according to that, people like yourself don't actually exist anymore in terms of the scientific conversation. I do want to talk more about the kind of, I would describe it as corruption of the science later. But I'm still trying to grapple with some of these things. So in terms of temperature, you mentioned about the funding around driving the story about global cooling, but then you said that the temperature cooling began to change. Are we now in a period of temperature rising? And if so, on what time horizon? What is the comparable period?
Oh, yes, absolutely. And, temperature is never stable. It's almost always rising or falling. I'm sure you learned about the Norse settlements in Greenland in the year 1100, when the south and the southwestern edges of Greenland supported farming that wasn't very different from Norway or Iceland. And then the weather got worse. It started getting colder and you couldn't make a crop. And so eventually all of those farms were abandoned, and the land was given back to the Inuit, it's still perfectly fine hunting ground for seal and for fishing, but it was no longer good for farming. So that was a major change, and that led into the Little Ice Age that for centuries made Europe in particular, much colder than it used to be. You know, I was a kid in Scotland, and my father was Scottish, and I remember walking up to the hills to the south of Edinburgh, the Pentland Hills, and you could see farmsteads there from, the year 1000, where people had managed to grow crops where you couldn't possibly grow a crop today. The growing season isn't long enough. So evidence was all around us that climate was always changing. It was always either warming or cooling. And we have begun to warm recently, I would say roughly the year 1800. Things really started to warm rapidly. That was long before the Industrial Revolution. But a good piece of evidence for that in my country is Glacier Bay in Alaska, which was charted by the great British explorer Vancouver in 1790. And he was a terrific map maker. He made wonderful maps of the coasts of Alaska, and you can navigate with them today. They're that accurate. But he showed no Glacier Bay at all. All he showed was a tongue of ice going out into the Pacific. So he had no idea there was a bay there. But 50 years later, most of that ice had gone, by 1870, it was all gone practically. And John Muir, the founder of the Sierra Club, a great environmentalist, a good environmentalist, made a special trip to Alaska and wrote a book about his findings. And the purpose of the trip was, why is all the ice melting in Alaska? And of course, then nobody raised the issue of it was because of humans driving SUVs, because SUVs hadn't been invented. So, yes, we are warming now. It's not terribly fast, but it's fast enough, for example, to melt the glaciers in Glacier Bay. And it's coming in fits and starts. I mentioned that there was this pause, and there was actually cooling from 1940 to 1980 approximately. And now it's warming again, but it hasn't been very much. And my own guess is that the recent warming has almost all been due to less cloud cover. We've got pretty good satellite information of that. And if you look at the cloud cover, it's been decreasing. And so if the sun can shine through and heat the surface, because there are not as many clouds, of course, it's going to get warmer. And what you observe is approximately consistent with that idea that most of the warming has been to less cloud cover.
Okay, so what you're saying then, just to correct me if I'm wrong, but you don't believe that CO2 is the primary driver, but it's actually cloud coverage is the primary driver. Are there other variables as well that contribute to the variances in temperature, in your view?
Well, yes, on a much longer period, plate tectonics makes a huge difference. So one of the theories for our current ice age, which I mentioned began 5 million years ago, that's approximately when the Isthmus of Panama closed. So for times earlier than that, 6 million, 7 million years ago, the ocean currents could flow directly from the Atlantic into the Pacific, and that made a huge difference to transport of heat and moisture between the equator and the poles. And so that had, of course, nothing to do with CO2, but it had a much bigger influence on climate than anything we've seen recently. So certainly geography of the Earth and plate tectonics is a big driver. Other possibilities are that the sun has been a bigger factor than anybody is willing to admit. Again, the problem is we don't have very good records of what the sun has done, because instruments are something of the last century. We just didn't have people observing 500 years ago or 1,000 years ago. But there are various proxies that suggest that the sun may have played a role in climate changes. When the sun is very active, the production of things like carbon-14 radioactive isotopes in the atmosphere changes. And so by looking at the amount of radioactive carbon in sediments, at the bottom of the ocean or lakes, you can estimate how active the sun was. And that does seem to correlate amazingly well with temperature, with the Little Ice Age, for example. So, for example, during the Little Ice Age, 500 years ago, uh, carbon-14, the radioactive carbon, was being made more abundantly than today. And so the arguments are kind of complicated, but that suggests that there were there were more cosmic rays, and the sun somehow was involved in deflecting cosmic rays or not deflecting cosmic rays. But there's a lot of circumstantial evidence that points to the sun as being much more important than people are willing to admit.
Yeah, I mean, that to me is, I mean, we used to have a phrase on the podcast which was common sense corner. We'd look at things that that just make practical sense even to the average person. And if there's variances in the sun, whether it's temperature of the sun or proximity, there are so many things you would expect, even micro changes, to make a difference on planet Earth. You touched on something I think is really important, which is, often when I look at the conversations around climate, they're so narrowly focused on the past 100 years or so, when the planet has existed for billions of years. Humans have lived for, thousands of years comparatively. So if I was to look at it, say, from an analogy of looking at the stock market, and we do some work in the financial markets, it'd be like looking at the last hour's data and making deductions about what's happening in the market from just that hour's patterns. And we could find correlations. We could say, well, the chart moved this way, and this is what happened out here, and this is why that moved. But then if we zoom out to the origin of the market itself, we would see many cycles repeat over time, and we would see various different factors that contribute to those cycles. And there's a complexity around what drives those cycles, because any financial market drives in cycles. That's my old background. We do a lot of work on this. And it's such a complex system. It's not a vacuum. It's not a singular variable that will alter the market. And if it does, that singular variable only is short term. It's only over a finite period. Whereas if we look at it from a systems view, we can see all manner of factors that impact the cyclical nature of markets. To what extent is the climate system cyclical? Are we, in the absence of being able, it feels like we can only really comment on the last hour. So how do we actually make assessments about the cyclical nature when our view is so narrow?
Well, certainly parts of it have to be cyclical because we have summer and winter. So if you look at climate, there are always annual cycles. That's hardly surprising. They're daily cycles, from night and day, so there are these huge drivers that have to do with the time of year and the time of day. So that's cyclical. But then there are many acyclical things that nobody quite understands. One of the major drivers is the El Nino phenomenon in the Pacific, where every 4 or 5 years, all of the warm water that's piled up near Australia and Indonesia drifts back toward South America and covers the entire Pacific with warm water that used to be pushed to the west. And so during an El Nino year, the whole Earth looks warmer from space because that vast area of the Pacific is covered with warm water on the surface. And nobody quite understands the El Nino cycle. It's not exactly 4 years, and sometimes it's very intense, and sometimes it just quietens down. There are analogous ocean cycles in the North Atlantic, between Iceland and these Azores, which are longer periods of time. They're more like decades, and similar ones in the Pacific and others that we probably don't understand yet, especially in the southern oceans, which are not as well explored as North Atlantic or the North Pacific. So, yes, indeed, they're cycles, but they're very poorly understood. And you probably know that the sort of how to call it, the fascination with chaos really began with climate. There was this guy Lorentz who was running climate models at MIT, and thinking that it was predictable, like, Kepler's orbits around the sun, or, Bohr's electrons and atoms, which are very predictable. What you predict is what you observe. This is amazing how well it works. And assuming that was the same for climate, when he tried to do that, he found that if he changed the initial conditions by just a hair, the final answer a day or two later was completely different, and so this brought up to the attention of people that there are chaotic systems, and climate is one of them, where very tiny changes in the initial conditions make enormous changes later on that are not even remotely like the little change in initial conditions. So climate has this additional problem of chaotic behavior. There are classes of differential equations that describe it, which you can now understand are chaotic, and that's the way they are. So it's a difficult system to make long-range predictions with, and the climate people know this, but they say, well, yes, that's true, but we'll get the averages right. And so I don't know whether that's true or not. At least it's a better argument than we voted that this is the answer.
I want to take a quick pause, because if you've made it this far into the episode, the chances are you already understand how rare it is to hear conversations like this. We live in a time where even world-renowned scientists are smeared simply for challenging the consensus. That's exactly why I created the DAG Supporter Program, a private community of free thinkers where debate isn't cancelled, it's actually encouraged. And as a supporter, you'll get early access to interviews like this before they drop publicly, invitations to join live recordings and Q&As, access to our private content vault protected from platform censorship. So if you're tired of being spoon-fed a single narrative and you want to be part of something that values truth over dogma, then head over to danastingregory.com/supporter to become a supporter today. I look forward to seeing you inside our Live Free and Prosper community. Now back to the episode.
Yeah, I mean, even with this, again, I have a hypothesis that with most things that have some form of cycle, if you zoom out far enough, the cycle looks predictable. But if you zoom in to a large degree, you'll see massive anomalies on the way. So again, using the financial cycle as an example, it's the human heart. If you look at a human heart, the pulse, you measure it, the circadian rhythm of, the rhythm of the natural rhythm of the heart. You zoom out far enough, it looks uniform. You start to zoom in, you can see there's all manner of anomalies, even on a day-to-day, minute-to-minute, second-to-second basis. And there could be various factors for that. But you look from a distance, it just looks uniform. And it would be incorrect to say it's completely uniform, but it would also be incorrect to say it's completely chaotic. It depends on, if you're zooming in, or how far you're zooming in, or how far you're zooming out. So there's unpredictable, even within unpredictability, in my view, within predictable systems, just as a natural order. But given everything we've talked about, why does the scientific community overlook the complexity of the system and all these various factors that could quite clearly contribute to the climate or variances in the climate?
Well, look, I mean, the scientific community is a huge collection of people in many different fields. The climate alarm community is a subset of it. And there, it's easy enough to understand. Their careers depend on this being important. They depend on generous funding flowing in from the government, funding agencies. And so, they can't really rock the boat. It's a little bit like this Norwegian play, that Ibsen wrote, An Enemy of the People. This little Norwegian town was famous for its spa. And the local doctor started noticing that people came to be cured at the spa often died, before they went home because they got infected with a waterborne disease from the spa.
Okay.
And so you would think that he would be welcomed as a hero, but the point of the play was that he was labeled an enemy of the people because it was, it was damaging the economy of the town. And so this is an understandable human trait. It's nothing to be proud of, but it's been around for a long, long time. So if you go beyond the climate community, Well, there's this sort of tribal instinct that, academics and scientists are really the best in the human race, and yet they're not recognized properly. Why does so and so make $1 billion in industry and he doesn't have a PhD and 10 graduate students? So there's a touch of envy in this, that society owes us something. We'll show them now that we're going to save them from climate disaster. And maybe I don't understand it, but I think it's a good narrative, so I will support it, even though I don't know a thing about it. Yeah, and so they get support from other fields, and especially from the more social science type sciences, whatever that means. Mm-hmm. It's a little harder for them to get support from mathematicians and physicists and, chemists, although they do get support there because they share in the wealth. But it's very easy to get support from gender studies or, sociology. And, those people don't understand anything about temperature or climate, but they're quite willing to sign up to a cause.
Yes. Yeah. I mean, they talk a lot about intersectionality and where you can see the intersections between the tribal factions that then become a movement around something, as opposed to, and it becomes ideological and radical, which to me is why when I look at this, I see it feels radicalized. It feels almost religious in its intensity, with regards to the obsession with the climate full stop. And even the climate movement. I'm someone, I would, on a scale of like 1 to 10 of inner hippie, I'm probably a 7. And as a result, I care deeply about nature. But to me, no one in the climate movement is even talking about nature anymore. No one is talking about pollution. They're just talking about a single factor that as you've described, it is largely beneficial to all human and animal and material life until it reaches a ridiculously high critical threshold where it potentially becomes harmful. Yet we're not talking about any of the molecules that did directly harm human life, animal life, plant life. We're just obsessing over CO2. And that, for me, raises serious alarm bells.
Greg, you're too young to remember Britain. When I was a kid, I would go to school or every morning in Edinburgh with a white shirt on like this. I'd get home in the evening, it was black all around here because of all the coal smoke, and everybody was coughing, they had, lung problems from all the smoke. That's all gone, so you can clean that stuff up. And not only the smoke, but the oxides of sulfur and nitrogen. You can design coal plants now that don't emit those either. Mm. My grandson just came back from China 2 weeks ago, and he said he was amazed at how clean China is. But China's run on coal, entirely on coal. But he said it was cleaner than America. And the reason is that they've got all modern coal plants. They're ultra supercritical. They've got the most advanced pollution control, real pollution I'm talking about. So there's no ash that comes out of the stacks. There's no oxides of nitrogen. There's no sulfur, no mercury. And so the whole country is pristine. You have bright blue skies. And again, I remember visiting China 30 years ago. It wasn't like that at all. It was a mess. It was just like Edinburgh in the 40s and 50s. So you can clean up the environment, and we should do that. And you can also walk around China and you see beautiful green hills, and you have seen rice paddies, and you don't see acres and acres of black solar panels or windmills chopping up birds and bats, So, the things that they're doing supposedly to save the planet are actually very destructive to the environment.
And this is so all of these things are what raised my alarm around this issue. I mean, my audience will know I was very critical of the COVID response for similar reasons. I'm concerned about the climate, and it becomes incredibly myopic. It becomes incredibly alarmist. the responses potentially cause more harm than the underlying problem. We're not here to talk about COVID, but the parallels to me were a warning sign to start looking at other areas where there is distinct alarm. My work in corporate leadership back in my former life in that world showed me that if you have leadership under pressure that is responding to alarm, they often make the wrong decisions, and they make decisions that are not grounded in pragmatism, rationality, evidence. They make emotional decisions that have further problems downstream. And I think this has been true in COVID. I think it's massively true in the climate space. I mean, one of the things I wrote down to talk to you about, if I can find the quote, because the consequences are so severe. Let me see if I can find it. I'm going to have to come back to it. But ultimately, we have policy decisions that are affecting millions of people based on this climate story around CO2. And my fear is if we don't course correct, then there's a lot at stake. I think the downstream consequences of a lot of the policies we're now seeing could actually have a far greater effect than anything that the intention of the original policy was designed to create. I mean, what's your view on the interventions we're seeing?
Well, it's hard to resist groupthink, especially if you're a corporate leader. You've got boards of trustees who want to look virtuous, and you want your company to look virtuous. So that's been a real problem. They've been convinced that CO2 really is a threat. And, I don't blame them too much because, there's been this massive brainwashing campaign, and, they don't know how to solve the differential equation. They don't know how to do a Fourier series like you do. And so they're very vulnerable to being misled, and they have been misled. I mean, the same thing happened when we were burning witches. My country, the last witch burnings were in 1690 in Massachusetts, and it wasn't led by the common people. Most of the common people were somewhat dubious whether there even was such a thing as a witch. It was led by, degree holders from Harvard University who had spent years being indoctrinated about the threat from witches and Satan. And so these movements are often led by the top of society, by the most educated, the best and the brightest. That's what led my country, into Vietnam. It wasn't the average guy who was going to die over there. It was the elite. So that's been a constant in human history, that leadership has screwed up. World War I didn't have to happen. It wasn't the fault of the soldiers in the trenches. It was the fault of the guys, in striped pants, around Europe.
Yeah, I mean, we've had Matthias Desmet on, who's a psychologist, who's explained how group dynamics work in these ways to create kind of groupthink and mass formation. It's been very interesting. You can really apply that lens over many different subjects, actually, in the modern world, particularly in the face of social media. But before we move on to talk a bit more about the scientific community, I am interested to dive into that a little bit more. But you mentioned earlier that clouds in particular could play a really, really pivotal role in the temperature variances that we're seeing. My brain immediately went to ask the question then, well, if clouds are so important, what is it? And this is topical because our last interview was just on geoengineering and different technologies that could actually seed more clouds. And the story in Texas has brought up lots of different conversations about geomodification, etc. Whether there's a link or not is obviously a big conversation that we're not here to talk about. But clouds, what is it that influences and historically influences the prevalence of clouds? If it's so important in driving temperature, is the influence of human activity playing a role in cloud formation? Is it a natural variable? What is it that's impacting cloud presence?
Well, for clouds to form, you, of course, have to have water vapor, and that comes predominantly from the oceans, but also from transpiration from the land. And you have to let the cloud form. It's not easy to form a droplet of water because, if the droplet is too small, it will re-evaporate before it grows. And so typically cloud particles form over cloud nuclei. Yeah, and these are bits of dust and dirt or salt particles. And, the geoengineers talk about, releasing enormous amounts of cloud nuclei. And it's not so much the cloud nuclei that does the engineering, it's the water that attaches to it. So there's a lot of water in the atmosphere, but most of it is in vapor form, which is transparent to sunlight. But if you can get it to condense into little droplets or snowflakes, then it is a very potent screen for sun. Or you can actually, if it's high enough, do the opposite. So to form clouds, you have to have sources of water vapor, and you have to have nuclei. And so my guess is whatever caused the Little Ice Age had something to do with a change in cloud cover, average cloud cover. And what drove that, nobody knows. But one theory by some very innovative scientists in Denmark and Israel is that it was galactic cosmic rays. Because when cosmic rays come into the Earth and all the way down to sea level, they leave behind trails of, charged particles. They rip apart the air molecules they go through, and those charged particles are good nuclei. They help the cloud droplets to form. And so they have, in fact, done a number of experiments that are suggestive that this may be right. At least they don't violate this idea. So they've gone to the trouble to actually try and test it experimentally. And then there's anecdotal evidence that this cloud formation, cosmic rays, is controlled partly by the sun, because cosmic rays, to reach the Earth, have to go through the magnetic field of our galaxy, which is good at deflecting them. And so if there are lots of magnetic fields in the solar system, like when the sun is very active and there's solar plumes going out carrying magnetic fields with them, they shield the Earth from cosmic rays. So we don't get as many cosmic rays. Therefore, we get fewer clouds because there are no cloud nuclei. And therefore, we get more sunlight. So the idea is that when the sun is very active and it's shooting out all of these, coronal mass ejections that we just went through a big one a few weeks ago, that we get more cosmic rays, or less cosmic rays, I guess. It's hard to get the sign right. And so less clouds, a hotter Earth. So an active sun makes a hotter Earth. And a less active sun lets more cosmic rays in. The resulting clouds keep the Earth cooler. That's the rough idea. I may have gotten a few signs wrong, but it's a very interesting idea, and it may be right. Yeah.
Okay. Well, I can see why people gravitate to CO2, because it's something you can just get your head behind. Whereas this
it has nothing to do with CO2.
yeah, because there's so many variables. Okay, so. And just on that point, I'm naive to all these things. Can those things now be? The cosmic rays sound like science fiction, something out of Star Wars or something. But can you actually measure these things now? Is there technologies to measure that kind of activity?
People have been studying cosmic rays for almost a century now, maybe a little longer. And the Earth has got a number of cosmic ray observatories that measure the counts of neutrons and primary cosmic rays. And for example, a few weeks ago, during this big coronal mass ejection, neutron count rates at sea levels went down by a factor of 2. They're huge, huge effects. They're not small effects. And so the data's there. It's there. It's pretty good for almost 100 years.
Wow.
And it certainly deserves at least as much attention as CO2.
Yes.
It might actually be right. CO2 is very unlikely to be a villain for very much climate change. I believe, just to be clear, I think CO2 will cause a little bit of warming, but it's certainly not the major driver of warming.
Mm, mm. So when we talk about climate science, and you've had your fair share of critics, even to say, as a physicist, you're not a climate scientist, but to me, when I look at what the climate science actually is, there's a whole range of fields that you would expect to contribute to it. And I even went to AI and said, what role does a physicist play in climate change? And it gave me, there was about 30 bullet points outlining all of the important skills and knowledge that a physicist can bring to the field of climate. From climate systems understanding, modeling and prediction, data collection analysis, reducing uncertainty, technological innovation, policy, public engagement. There was just an endless list of things that a physicist can bring to the science conversation around climate. Yeah, it's almost like this idea of climate scientist is this little group of people who gather in the 97% to agree on their one view on things. But you've had a long and distinguished career at Princeton as a physicist. You were a former science advisor to the White House. You're a world expert on atmospheric physics. I'm curious, at what point did you turn your professional credentials to climate? I'd love to hear your backstory about, what led you to look at this. And I'm curious, were you one of the so-called 97% when you first started out?
Well, I got interested in this in the early 90s when I was director of energy research at U.S. Department of Energy. So I had all of the basic research funding from the Energy Department, non-weapons. Weapons was always separate because of that classification. And so I thought it would be a good idea if I were asked questions by Congress on how we were spending the taxpayers' money to be able to explain what we were doing. Mm. So once a week, I would have some principal investigator come in and tell me about some topic we were funding. So people would come from high energy lab, from Fermi Lab, and tell me about the search for the top quark, which had not been discovered then, and how it was going. Or people would come from the Human Genome Project and tell me what was the cost of a sequencing machine this month, and how fast was the cost going down, and what had we learned about the human genome. And or people would come in from some deep drilling experiments we were supporting, to tell me about bacteria living happily at 10,000 feet underground, oxidizing, kerosene and sulfate. And so, wow. So it was all very interesting, and it was helpful to me because I was able to make, sort of a few sentence speech, to answer any question about all of these fields. I knew what was important. And we were also supporting climate. And so when we would invite someone in from the climate area, frequently they would refuse to come. And they said, well, we work for Senator Gore. And I said, well, okay, if he's your sponsor, ask him next year for funding, because I can use your money for someone who'll come and brief me next year. So then they would get very angry and come and give a hostile talk about what they were doing. And it was all very hush hush, and I really can't tell you this, this is too secret. And nobody else was like that. So it was a completely different sociology in climate from all of the other areas. All the other areas were very similar. They were just thrilled with what they were doing. They were excited about it. They couldn't wait to tell other people about it, proud of what they were doing, and could defend it. And climate, it was all very conspiratorial, So I knew then there's something funny about climate. I hadn't really paid much attention, and I knew a lot about the atmosphere because I was invited to Washington for solving of an important atmospheric problem in the days of the Strategic Defense Initiative. So no one was better able to understand what they were doing in climate than I was. I knew more than most of them did, because I knew a lot of the classified information. But when Clinton and Gore were elected in 92 or whenever it was, of course, I had been serving a Republican administration, so as soon as they could find me, they fired me. I was happy to be fired. I was delighted to go back to, back to Princeton and my my own research, so I never was against them. But I was so consumed by our own work back at Princeton for several years that I just ignored all the nonsense about climate. But it was getting rapidly worse with with Al Gore in the White House, and but I would occasionally watch television in the evening with my wife, and I would get upset when there would be some nightly news report which was just completely phony, but planted by the climate community. I said, well, this is all a lie. None of it is true. And my wife would say, well, how would I know that? I'm a nurse. I don't know anything about physics or climate. If you think it's so dangerous, why don't you speak up? And so I owe my activity to my wife, Barbara, who got so tired of listening to me complain. She said, if you're serious about it, get out there and educate people. So that's what I've been trying to do.
Wow. And as you dug deeper, was this what shocked you most as you started to really look through the lens of a physicist on this?
Well, I think the thing that upset me most was the enormous exaggeration of the warming effects of CO2. CO2 was something that I knew a lot about, more than most of them, because one of our first high-power lasers in the United States was a CO2 laser. We could make megawatts of power with it. And so I knew everything about how that worked, the nuts and bolts of CO2 molecules, how they vibrate and rotate. And so I knew a lot more about its radiative properties than the climate scientists. And I knew there's no way it could cause that much warming. It's got this problem called saturation that if you add just a little bit of CO2 to an atmosphere that doesn't have any CO2 to begin with, it has a huge effect. It rapidly decreases the cooling radiation to space, and so it will rapidly warm the Earth. But as you add more molecules, they start getting into each other's way. You are rapidly reaching a sort of a law of diminishing returns. You're familiar with that in the finance area. You can invest too much in something. There's a sweet spot. And we passed the sweet spot for CO2 long, long ago. So the warming from an added CO2 today, compared to some hypothetical time when there was no CO2 at all in the atmosphere, it's 10,000 times less. So that's saturation. So it's not a small effect, it's a factor of 10,000. It's a huge effect. So yes, adding more CO2 does warm the Earth a little bit, not very much, because we're so far into this law of diminishing returns, which nobody really understands outside of this narrow field of people who've actually looked into the nuts and bolts. And so most people think, well, if you double CO2, you'll double the warming, or you quadruple it, you'll quadruple the warming. No, not at all. It's got this. I'm sure you're familiar with a logarithmic response, but it's a logarithmic response, so it's very, very, very slow.
Yes. Okay. And you attribute your wife to encouraging you to speak out, and in a way, my life in the last 5 years has a similar story, and some of the things I've spoken out on, because my wife was fed up of me just chewing her ear with all these things. So I've dedicated my professional career to doing that with the show, but it's come with a lot of different challenges and costs, critics, and I'm sure it's no different for you. So how has it impacted you personally and professionally, having taken on the challenge of refuting the dominant climate narratives?
Well, I don't think it's affected me personally very much. I mean, compared to lots of other people, I had the advantage that I was already pretty well established before I started speaking up against this. And, it's almost suicide to do that if you don't already have some independence, because the climate alarmist community is very vindictive. They will take revenge, but it's a lot harder for them to do that to me than to a young person. So that I was able to hold my own because of my independent stature. It did mean that I was a member of various supposedly elite organizations, the Academy of Sciences, and I'm a pretty good spokesman, and so they initially thought to draw me into their management structure there, but I said, well, I'm not going to cooperate unless you tell the truth about climate. And well, they weren't willing to do that. So although I'm still a member, I've basically ignored them now for 15, 20 years, And so in some sense, that meant that I lost the opportunity to feel important around the world. But that never appealed to me very much anyway, so it wasn't a big loss. And I don't know, in the university at Princeton, I'll say this for Princeton, they occasionally get irate letters from alumni demanding that I be fired, because I'm questioning their religious beliefs and climate. And on every occasion that I know of, the administration has written back a letter telling them to go to hell, right? They have to put it bluntly.
Yeah.
So they've stood up for what they should stand up for, which is, academic freedom. So I have that right, and not every university has done that. Many of them have caved in to the fanatics, but Princeton has held firm so far. I hope they will continue. So it's not really been a big deal to me. In fact, I've enjoyed learning a lot more details about climate-related physics I would never have worked on otherwise. And so I'm working now with a colleague from Canada on details of how water, ozone, and other molecules absorb and emit radiation when they rotate. And it turns out that basically a third of the greenhouse effect in Earth's atmosphere is from rotations of water molecule. Water really dominates the greenhouse effects. CO2 is not trivial, but water is much more important. And some of that physics is very interesting. It goes back to, the 1700s. The first guy who really looked at the related physics was Leonhard Euler, who worked for Catherine the Great. And so I'm still using some of the equations that Euler wrote down in 1760 or thereabouts. He was a smart guy. And of course, physics doesn't change. We don't amend, the law of gravity. The law of gravity is still the law of gravity. You can't amend it or repeal it. So anyway, I don't feel that I've suffered in any way.
Yeah. Now, I'm really pleased to hear that. That's the positive, and it's obviously fueled you to continue your work. I mean, the problem we have here is that, from a public perspective, they're repeatedly told that 97% of the scientists are in agreement, and dissenting voices to that 97% are smeared or deplatformed or censored. And we've seen it in other fields. We saw it during COVID. Can you give us a kind of a more balanced view on the scientific field? Are there lots of other scientists like yourself who think the way that you do and challenge the dominant narratives? And why is it we don't hear from them? It's so difficult to navigate the field of information, to find people like you who are credible, credentialed. Can you give us an extent?
There are lots of people like me, and in our country, we've set up a little group called the CO₂ Coalition, and we recruit other scientists and engineers and economists who don't buy the story that CO2 is a demon, and we've got 200 or 300 members. They're all PhDs. I will say that the great majority of them are at retirement or close to retirement. So like me, they're not worried about being fired. They have job security. And we go to some effort to not recruit young people whose careers could be damaged by coming out and speaking the truth about CO2. But by no means is there a 97% of scientists who actually know anything. If you look at that figure, it's been looked at by many people. It's a completely phony figure. I mean, for example, one of them, they asked, do you believe that climate changes, and do you believe that man has something to do with it? And, it was questions like that. I would have answered yes to every one, so I would be one of the 97%. But it never asked the key question, do you believe there's any danger? Is there an existential threat? In which case, most would have said, of course not. It's very interesting, and like many other things in nature, very interesting, and we should work on it. After all, it's important. Climate has been at the center of mankind's history forever. Joseph went to Egypt, because there was a 7-year famine, there was a 100-year famine in Canaan, and the only place where you still had agriculture was Egypt, because they had the flooding of the Nile. And, why did that happen? And there's good evidence that will happen again, and we should understand that. It would be very useful. So I'm a big fan of real climate science. I think that it's a good investment for government. It's a good investment if you're just a philanthropist, but you should get people who are willing to tell the truth, and they're not fixated on trying to prove some narrative or another. What are the real causes?
I mean, presumably, we've touched on it a bit. Presumably, within the course of history, there have been periods where the planet would have been so warm or so cold that the scale of human life that we have today would be threatened by that. But how do we assess what would, a possible timeline for such a period to emerge again?
Well, I think we talked earlier about the fact that we're in a ice age now with periodic glaciers covering Canada, Scandinavia, parts of the southern hemisphere. That most people think that has something to do with the orbit of the Earth around the sun, the obliquity of the axis of the Earth, and if you look at those parameters, they are changing, but they're not like the ones that triggered the last few ice ages. So we certainly have, 1,000 years, several thousand years to understand that. There's no rush to understand what caused the big ice ages. But that's plenty of time to completely screw up the world, if we continue these idiotic, net zero policies, which are extremely damaging to economies, are very damaging to scientific integrity, just all sorts of problems with them, much like COVID that you mentioned earlier.
And with the net zero policies, again, it's to me, it's the humans have been given a warning over time and time again that if you interfere with natural cycles and natural order, we will pay the price. And that's my fear with all these innovations now. There's massive conflicts of interest. People talk about, big oil and fossil fuels having conflicts of interest in challenging climate science, but they work both ways. It works completely both ways. There's an industry now, a huge $1 trillion industry behind net zero. And you can't ignore that in its role in upholding the idea that CO2 is the dominant problem. It's a massive conflict of interest. It's a huge emerging industry. I mean, we touched on geoengineering. That's a huge field, and much of that is growing in the idea of tackling climate change in the way it's being presented. So
no, you're right. There is an enormous conflict of interest on the side of the climate alarmists that people can't seem to recognize. In both cases, they're massive forces, pouring money into bribing politicians. And that's true that the fossil fuel companies used to do that too. I presume they still do it. But there's one big difference. The fossil fuel companies make life easy, healthy, extend longevity. You can take a vacation in a jet plane. The climate alarmists make life miserable, brutish, and short. So which one should you pay more attention to? The one who's going to drive you into poverty and slavery, or one that gives you freedom and health?
Yes, I mean, if you put it that way. I mean, to that point, then, who do you think benefits most from the climate alarmism? And how has the narrative been captured? Because it's politics, it's media, it's big finance, it's an industry, it's an industrial complex.
Well, we talked about my community, which has benefited from all the funding, so no need to talk about that again. Politicians have convinced themselves that it's a winner, that they will get elected to office if they support it, and so you can understand that. Politicians have never been noted for, strong moral principles. And, but then the great mass of people who support it are hungering for a cause, that's bigger than themselves. They really are good people at heart, and they feel like my life should be worthwhile. I should be doing something important, and saving the planet can't be beat as a goal, So if you're saving the planet, you can go to sleep every night and thank God that you're so virtuous, in your prayers. And so that's a need that people have, and it's not being fulfilled in any other way. So I think if we could provide them with a real goal which actually help people instead of harming people, then that would go a long way to diffusing all this nonsense. But I don't know how to do that.
Well, I mean, that leads me to my next question, which you may not be able to answer in light of that, because you can't even buy a paper cup now without learning about its carbon footprint. The narratives are so entrenched. What do you think it would take to start to challenge the dogma around it? Can evidence win true in this? Because you absolutely connected with the point that we found during COVID. If you try it and simply win the argument on evidence and rationality alone, it's very hard to permeate something that is deeply emotionalized, ideological, or even dogmatic. So how can the dogma turn around, do you think? Is it possible to change the direction and the course of the conversation at scale?
Well, in our country, we've just elected an administration that's busy dismantling the climate alarm establishment, and is going full guns. And, they have lots of critics, but climate is not attracting a lot of opposition, So this idea that politicians have that this is a winning a vote getter, it's not true. At least it's not true in the United States. And I would guess that's true of Britain. It's true of Australia, of most of Europe. So, that type of leadership will help. Our witch trials ended in 1690 because after they ran out of easy targets to hang, and they started accusing each other of being witches.
Yes.
And all of a sudden, due process suddenly became important, and evidence became important because I've just been accused of being a witch. I'm not a witch at all. How dare they? And so one of the simplest things they did was they got rid of what was called spectral evidence. Many of the witches were hung because young women about Greta Thunberg's age said, I had this dream, that so-and-so was consorting with the devil, and it was very real. I saw Satan dancing with this woman, and that was good enough for the court, this dream of this innocent young girl, and so they hung them. And then the girls started dreaming about, the Harvard professors, and all of a sudden, the rules of evidence changed, and you could not use spectral evidence anymore. And so I think, some version of that will eventually happen with climate, even in Britain and Europe. The politicians will turn on themselves, and then all of a sudden you'll see rationality that should have been there a long time ago.
Yeah, I think we're starting to see the beginnings of that happening. Actually, it's going to be turbulent along the way, I think, but I think we're seeing the origins of that returning.
It's too bad about the people. People do get brainwashed, and it's almost impossible to unbrainwash them. The Vegas, an old example of that was, Moses leaving Egypt with, the enslaved Hebrews, and he did manage to get them out of Egypt, but they were unable to get rid of their slave mentality. And so he had to wait 40 years for everyone born in Egypt to die and, have a new generation that was raised up without this brainwashing that you're really fit only to be slaves. And so we may need 40 years. At least that was an experiment that was done a long time ago, and that's roughly the time it took.
Wow. Okay, buckle up.
Yeah.
If you personally could rewrite the climate conversation from scratch, what would a rational, life-affirming approach look like to you?
Well, I was always, when I was at Department of Energy, I put as much money as I could into instrumentation for measuring properties of climate, amounts of CO2, temperature, winds, and as opposed to computer models. So I would try and keep funding comparable to what it is today, but switch most of it out of models. You need one or two models maybe, but most of it into instrumentation so that we have good measurements that are well calibrated, both from space and from land and in the oceans. I think that is a really good investment of taxpayers' money. And it needs to be archived carefully and not lost. And, and it's not easy to measure something right. Your instrument may be miscalibrated. And so you have to have really good people doing that. And so anyone willing to do that would be doing a great service to the future of climate and to humanity, because that's the starting point, is having reliable data.
Oh, absolutely. And then following that, we've talked about some of the tribalized groupings that have been captured by the narratives, but amongst all of that, there are a lot of young, well-meaning people who want to make a difference with their life. What would your message be then to them? What values should guide those who are keen? I mean, the word environment doesn't even get used anymore. It's all climate. But what values would you say would guide environmental stewardship for those who are on that path of trying to make a difference for the planet?
Well, first of all, I would advise them to pay close attention to their local environment. So if they live in some township where there's rapid development, everything is being paved over by asphalt, or housing developments, that they go to town meetings, zoning council meetings, and point out that this beautiful area is being messed up. And, what are you doing about it,
Yeah.
for the people who live here? So I would begin at home, to, and then, there are things that transcend your own little patch of the world, but that should be secondary, that's important too. But I would prioritize from your local region up. And instead, the current movement, it's sort of global. We start from the top down, and if you really look at what's happening, actually, it's doing just the opposite. It's covering the land with all these horrible solar farms and windmills. And so I don't think they would have done that if they started from the bottom.
Yeah, I mean, yeah, top-down centralization to me appears to be the biggest problem facing humanity of all, because you get one-size-fit policies, you get groupthink, you get all of the things we've talked about. What could ordinary people do to begin to think critically about the climate narrative? Where can they find? You've mentioned your coalition. Where should they start to find credible scientific resources that aren't so filtered through ideological lenses?
Well, that's a good question. One thing would help a lot is to try and make sure that you learn more about the basic physics, the basic chemistry that's involved. One problem now in climate education is you get educated on how to contact your local legislature and not, how, how do the laws of physics and chemistry work, which are really what you should learn. So I would say try and make sure that they look into the basics as best they can. It is hard because to really efficiently understand climate and other things, you have to have a knack for mathematics, and you have that, but not many people do. And it's very hard to describe many of these things in words, whereas if you had one or two line equation, it's crystal clear. And so people who are innumerate, and some, some of my children are that way, so I sympathize. They just basically are not wired up the same way as I am, and they're very great. They're great people, but we're all different. But anyway, if you can increase your mathematical tools for understanding this would help a lot. And there are certain people who would find that fun. They like puzzles, and this is a lot like a mathematical puzzle. The basics are not very complicated. The Earth is warmed by the sun. That's where the heat comes from. And if the sun kept pouring heat into the Earth, we would soon boil. We really would have global warming, but we don't, because the Earth radiates that heat back to cold space. So what we're doing is we're taking solar heat and we're dumping it into the cold space around the universe, and that is affected. The efficiency with which we can dump heat into cold space is hindered a little bit by carbon dioxide. It's hindered much more by clouds, hindered or helped. It can have either sign. But the basic idea that we're trying to tune a fine balance between solar heating and infrared cooling to space is the key to understanding the climate. And it's a devilishly complicated problem, even for, professionals, for physicists, because it's fluids, and fluid physics is one of the hardest parts of physics because of this chaotic nature that we talked about earlier. The laws of the Navier-Stokes equations are nonlinear differential equations, and they have chaotic solutions, so they're very hard to solve. A lot harder than quantum mechanics or E&M or other things where everything is nice and linear. And so even though the basics are simple, that it's solar heating and infrared cooling, all the details in between are just horrendously complicated. And so there's lots of room to get confused. And even the best physicists get confused, So ordinary people should not feel bad if they're confused. There's a nice story about this after World War II. Heisenberg, who had led the German atomic weapons effort, was forbidden to work on nuclear physics by the Allied governments. And so he decided he would work on fluid dynamics, which was another hard subject. He had invented quantum mechanics. He's one of the inventors. So he was a very bright guy. He was a terrible administrator for the weapons program. So, the Allies lucked up there that if they had gotten someone competent, we might have faced a nuclear Germany. But Heisenberg screwed it up. So that was great, because he was a bad manager of people. But anyway, he went into fluid mechanics and discovered, wow, this is really hard. This is hard compared to quantum mechanics. So the joke, maybe it's true, is one of his young associates said, well, Professor Heisenberg, they say that, if you've lived a good life, when you die and you finally go to heaven, you get to ask the Lord, 2 questions of any topic of your choosing, and he will answer both of them. And what will you ask the Lord, when your time comes? And Heisenberg thought for a little bit, and he said, well, I think I will ask, why turbulence in fluid dynamics?
Yes.
And why relativity? And I think the Lord will have an answer to the second one.
Right.
So I tell you, in Heisenberg's view, the physics of the Earth is too complicated even for God.
Yes.
So it's no wonder we're having a hard time with it. It's a hard subject.
Yes. Yeah. I mean, we haven't got time to talk about it, but I mean, looking at AI and things like that, AI could potentially help with some of these things, but it's so programmed with the narratives at the moment that actually you get a self-fulfilling loop based on what's already in there. So, the opportunity though to actually feed artificial intelligence and large learning models with alternative perspectives, I think will create pioneering discoveries, or help to create pioneering discoveries. I want to close out by asking a little bit more about your CO₂ Coalition. Tell us a little bit about what people can find there, and what to expect if they look up your work.
Well, CO₂ Coalition we put together about 10 years ago now. It was a small group of mostly academics. There was myself, there was Dick Linton was an original member, Pat Michaels. There were people who knew a lot about climate and were unhappy with all of the exaggeration. And so we thought, instead of just wringing our hands, we should try and get the information out to our fellow citizens. So the whole goal of the CO₂ Coalition was to explain to people the facts about CO₂, that it's actually beneficial to life, that you can see its effects on agriculture already, agriculture increasing productivity, and that its effects on climate were not zero, but they were hugely exaggerated. And so the benefits far exceeded any harm from more CO₂. So we've grown since then, and we've got a very vigorous executive director now, Greg Wrightstone, who's written books himself. He's a geologist, and so it differs from most other organizations is that most members are professional scientists or economists or engineers and one sort or another. And so most of them are relatively numerate. And so if I had any criticism of it, it maybe is a little bit too nerdy for, for the average person. But we've tried to suppress that. So you'll find many articles on the website that are easy to read. We have a particularly good op-ed writer from India who Vijay, who every week or two has a terrific article on how climate policies are affecting India and undeveloped parts of the world. And to their credit, both India and China have done common sense things, and maybe they will lead us out of this stupidity. I hope so. Maybe the U.S. will lead us out of it. That's also possible.
I mean, obviously, we've touched on the absurdities of net zero, but do you see any benefit in striving to reduce CO2 in the atmosphere? Is there any purpose to do that?
No, I think it actually harm, because it's clear that the net effect of CO2 is positive. The social cost of carbon is negative. The more CO2 the better it is for the world. So it is just, it's all pain. There is no gain whatever.
And my last question to you is, if future generations look back at this period of climate alarmism and see it as mass delusion eventually, maybe in 40 years' time, what do you hope your legacy will be within this?
Well, I'll be dead in 40 years, so I really won't care. But I I hope that my efforts and those of many, many like me, I'm not the only one by far who's been trying to bring rationality back to this topic. I hope it will speed up the collapse of this delusion, because the longer it lasts, the more damage is done. And so it will sooner or later collapse, because, net zero is suicide. It's a suicide pact. Nobody wants to commit suicide. So it will collapse sooner or later, no matter what I do or other people do, because people won't commit suicide. But in the meantime, enormous damage can be done before it's finally clear that, I'm not going to jump off this cliff. And so it's better to stop it sooner than later. So our whole effort has been focused on trying to stop this as soon as possible, because we know it will stop. It doesn't depend on us to stop it. It will stop of its own.
And my last question is, what would be your one message to the so-called 97%? What's the one thing you'd want them to look at more thoroughly in order to start to change the conversation?
Well, I would say, you ought to look into your conscience, because, real science is questioning the way the world is. Is this really true? How do I check it? How do I disprove it? And so many of the great advances in science were disproving things that everyone believed, but they weren't true at all. And COVID establishment, climate establishment is just the opposite. There's a agreed on narrative. There's a party line, and you support it or else. And if you're doing that, you're not in the traditional mode of science, that we're also proud of. And it's quite the opposite. You're in the mode of being a religious zealot. And, zealotry of every kind has always been bad news for mankind. And it's not any different with climate or COVID.
Yeah, absolutely. Dr. William Happer, thank you so much for helping us to challenge the narrative here on the Astin-Gregory podcast, something we take great pride in doing, to try and pursue truth and wisdom. And you've helped us open up this conversation, our first here on the podcast, looking at the grand narrative of climate change and helping us to pioneer our discoveries and discussions in this space. And I really appreciate this evidence-backed discussion. You've inspired me to look at this with open eyes. I thrive at looking at complex, meaningful problems, and you frankly blow my mind at the extent of angles that I can go on and explore further on here. So I thank you for that. And I'm sure on behalf of our audience, praise in the work that you're doing. So thanks again for being with us today, and really appreciate your time on the show.
Dan, thank you for the chat. I enjoyed it.
That's it for today, and I hope you enjoyed this important conversation. It's one that really needs to get out, so please hit the share button to expand the debate and help us break the illusion of consensus. Whether you agree with Dr. Happer or not, the point is this: science is not a religion, and it is far from settled. It should never be shielded from challenge, debate, or scrutiny, especially when public policy, livelihoods, and future generations are on the line. And what's coming next makes this conversation even more urgent. In our next episode, I sit down with Catherine Ybarra to dive deep into geoengineering, exploring what's already happening in our skies, who's behind it, who's funding it, and why it's all being done in the name of saving the planet. It's an interview that shook me, and one you do not want to miss. It made me realize that the climate debate isn't just about models and policies. It's about massive, unaccountable, undemocratic experiments with our atmosphere. So if you want to go deeper and never miss what's coming, then here's what to do next. Number 1, please hit subscribe now so you don't miss the next episode. 2, in today's climate, pun intended, even fact-based conversations like this can be censored. So head to danastingregory.com/podcast and join our mailing list. This ensures that we can stay connected no matter what happens on these platforms. And number 3, if you value independent, uncensored media and want to help keep conversations like this alive, then please consider either making a one-off or monthly donation at danastingregory.com/supporter. As a monthly supporter, you'll also get early access to our mind-blowing conversations, including our upcoming episode with Catherine Ybarra. And every single contribution helps us to stay independent, reach more people, and keep asking the hard questions, even when it's inconvenient. Thanks again for tuning in, for thinking critically, and for being part of this movement. Until next time, my name is Dan Astin-Gregory. Live free and prosper.